Hello, 30-1 friends. Here we are in our second lesson of function operations. In this lesson, we're going to do multiplying and dividing of functions. The good news is if you followed along with adding and subtracting, multiplying and dividing is going to go very well. The only place we're going to have to pay a little bit of special attention is when we're dividing. And we'll talk about that in just a moment. Make sure you've got your graphing calculator with you, because what we want to do again is just think about how do we multiply these functions together or divide them together, and what is the end effect that we get when we do that. So one of the things I want you to think about going back to the last lesson is when we were adding or subtracting functions, what we ended up doing was we ended up adding or subtracting only the y values. So take a look what I'm going to do here. I've got x squared and x, and maybe I'll make it x plus 1 just for fun. Why not, right? But what we're going to end up doing this lesson is I'm going to multiply these things together. So in y3 here, what I'm going to do, well, I'm going to multiply these things together. So I'm just going to put it like this, x squared times x plus 1. No real reason for me to multiply that out fully. Wouldn't be too difficult. Okay, I hit graph, and so I'm going to see there's x squared, there's x plus 1, and here comes our cubic function, our polynomial, which we know what that would look like. But let's look at our table of values like we did in the last lesson. So I'm just going to, again, notice there's only one x value because we're not changing the independent variable. So let's look at our y values. So what we can see here by analyzing our y values for when x is 0, on the first function, y is at 0, and on the second function, y is at 1. So when we look at the multiplied function, 0 times 1 is 0. And let's go back and let's look at something different. Let's look when x is 1. Well, when x is 1, y is 1 on the first function, y is 2 on the second function. So when we multiply those together, we get y is 2. And we can keep going like this over and over and over. X is 2, we get y is 4, y is 3. So the combined multiplied function's at 12. Okay, so the same rules apply from the last lesson. When we're adding or subtracting, we would only add or subtract the y values. When we're multiplying or dividing, we will only add or multiply or divide the y values. Okay, so one more time, we're only affecting the y values here. Now, like last lesson, we have two different ways to write these in terms of notation, this or this. Okay, I prefer the first way. The second way doesn't bother me, but I just need you to focus in that solid dot means we're multiplying. In the next lesson, we'll see an open dot, and I need you to recognize the difference between those two things. Okay, division, again, we've got two different ways to write it. I mean, it's not bad. The thing we need to watch out for in division is this. It says g at x can't be 0. Well, why can't it be 0? Because we can't divide by 0. So here's where we're going to start having some important things happen. So let's watch for that as we go through the next examples. So I've got a pretty graph here for you, two pretty graphs. And one's a quadratic and one's a linear, very similar to what I just drew for you on my calculator. Okay, let's take a look at these and let's answer some questions doing some multiplying and dividing. So let's look at these two cases. Let's look at part A. Part A says f at -4 multiplied by g at -4. So what we do is we go to f, which is our linear function. Well, f at -4 is right there. So we multiply the y value, which is 0, times the y value of g, which is right there, and that's 8. And so we multiply those together, and that's 0. There we go. If we wanted to think of this as a coordinate pair, we just created a new coordinate pair. The input was -4 and the output was 0. That's it. B. Well, B is this slightly different notation with the solid dot. What I prefer to do is to rewrite it in this notation. I just like it. It looks a little cleaner to me, but again, that's up to your personal preference. So what does it say? It says F at 0. Well, F at 0, the output is 4. G at 0, so the input is 0, the output is also 0. So there we go. 4 times 0 is 0. And again, if we're thinking of this as a coordinate pair, the input was 0, the output was 0. That's it, friends. That's how we multiply functions together. We're going to multiply the y values together when the x values are the same. Let's do some division now. Okay, let's just look at two division questions. So C says, let's say G at 2 is divided by F at 2. So what I'm going to do is, again, I'm just going to erase these dots here. I'm going to go back up to my graph, and I'm going to say, okay, when X is 2 for G, so I just got to make sure I get my order right. Well, when X is 2, my output also happens to be 2. And F at 2, the output is 6. So I divide those two things, and there we go. We would get a point at 2, 1/3. Not bad. Okay, it's D that I really need you paying attention to. With division, I need to be careful about division by 0. Well, I kind of gave away what was going to happen. So this says G at -4. Okay, G at -4 is up here. It's at 8. Divided by F at -4. Well, F at -4, the output is 0. Okay, we can't have that. We're dividing by 0. So what ends up happening here is this is a discontinuity. We've got actually a discontinuity. It's going to end up being a vertical asymptote. So when we're doing division questions, I want your spidey senses tingling. I need you looking out for division by 0. Okay, so what we've learned so far is we're going to multiply and divide, same as we add and subtract. We only multiply and divide the y values. Now, one last question I want to take a look at here, and we are done. All right, last question we're going to consider. State the domain of f times g at x. Okay, this is a really important question, friends. We've been getting this quite a bit on our diplomas the last few years. So how do we attack this thing? Well, the good news is all we need to really do here is we just need to analyze the domains of each of the individual functions. So we're going to look at our graphs here. So let's look at the domain of f at x first. So the domain of f at x, well, I see it's this solid dot right here at -5. So my domain would be -5. And my graph goes to the edge, which means it keeps going to -infinity. The domain of g at x. Okay, well, the g at x domain, well, it's a parabola. Again, it goes to the edge of the graph, which means it goes on forever. So the domain is this. So what's our domain when we multiply these things together? Well, all I need to think about is when I'm multiplying functions together or adding them or subtracting them or dividing them, is I'm finding when x values are the same and I'm performing the operation on the y value. So like I'm just kind of drawing on the graph here, I could multiply the y values together when x is 3. I could multiply the y values together when x is 1. I could multiply the y values together when x is -2. I could multiply the y values together when x is -4. I could multiply the y values together when x is -4.999999. But I can multiply the y values together when x is -5. It'd be somewhere up at the top there. But I can't multiply the y values together when x is -6 because why? Well, there is no x equals -6 on the linear function. It doesn't exist. So what will my new domain be? Well, my domain can only be where both of these graphs exist, where they coexist. You could think of that as saying the domain will only be where the graphs overlap, is maybe a more visual way to think of that. So where do these two graphs overlap? Well, starting at -5. That's where they're both going to overlap. So the domain of f times g at x is where these graphs overlap, where they coexist, where they have a co-domain, just like that. Okay, so a domain of a adding, subtracting, multiplying, or dividing operation, I need you to be able to tell me by looking at the graphs. Okay, I really need you to be able to do that. That's very important as you're going through the lessons. Okay, let's wrap this up then. So the final thing I want you to remember is when performing operations like multiplying or dividing, the only value that will change is the dependent, the y value. Do not touch the x value. And the other thing I want you watching out for, watch out for division by 0. That's it, friends. A quick lesson. I hope that worked for you. I will see you in the next one, which is composition of functions.